Hi everyone. Today we're going to be talking about yields, and that is in respect to stoichiometry and quantities in chemical reactions. But before we do that, let's do this quick warm-up. Just a review of our basic mass conversions in stoichiometry. So we're asking how many grams of water are produced by the reaction of 7.5 grams of hydrogen gas. So we're given 7.50 grams of hydrogen. We want to know, our question mark is how many grams of water. So our given is hydrogen, our wanted is water. And just to remind you, we follow these steps, going from mass to mass. We'll need 3 conversion factors, and they'll look just like what we have in our map there. So starting with 7.50 grams of hydrogen, my first step is to convert that to moles. So it's 1 mole of hydrogen, and then I plug in the molar mass of hydrogen, which is 2.02 grams. Right, that's just 2 times what's on the periodic table. When I do that, grams of hydrogen cancel. Now that I have moles of hydrogen, I can use the mole ratio to convert to moles of what I want. So moles of hydrogen go in the denominator, and moles of what I want, H2O, go in the numerator. And in the balanced equation, it's a 2 to 2 ratio. So that's what I put in front. For the mole ratio, that's the only time I have to look at the balanced equation. Right? And then my final step is to convert moles of water to grams. So here I do 1 mole H2O, and the molar mass of water is 18.02 grams. Okay, that cancels out moles of water, and I just have to run that through my calculator. And when I do that, I got 66.9 grams of water. So that's our mass conversion, and we'll be doing some more of that today. That'll come into play in our yield. So our goals for today are to explain the difference between theoretical and actual yield, and then when we have both of those, to calculate the percent yield. Right, so think about a recipe. If you have a recipe for chocolate chip cookies, and it says right here, the yield is it makes about 28 cookies, right? That's the kind of yield that we're talking about. In this recipe, yield means makes. So when we're talking about yield in chemical reactions, it means exactly the same thing. It's how much product you get, right, or you should get based on the amount of reactants that you put in. So yields are always the things that you make. It's always related to the product. Now there's a couple of different kinds of yields. One kind of yield is the theoretical yield. Right? And this term confuses people sometimes because they're like, theoretical, I don't believe in it, right? It's just a theory. But we all know that's not what the term theory means. Instead, what theoretical yield is it's just the amount of product that you would calculate to form. Okay, so if you're not actually doing the reaction in the lab, but instead using a pencil and paper and the periodic table to calculate, like we just did in our warm-up, how much product would form, as long as we're calculating an amount of a product, that is a theoretical yield calculation. Right? It's theoretical because it's paper and pencil, not a number that you get in the lab. So any of the calculations we've been doing so far, right, this morning or in our notes last time, those are considered to be theoretical. So don't let that word trip you up. It just means that you're calculating it using paper and pencil. So I could ask this question, right? What is the theoretical yield of Fe2O3 when 5 grams of Fe is reacted with unlimited O2? Right? Since my product is Fe2O3, finding a theoretical yield is just asking how many grams of Fe2O3 form. And the given that we have is 0.500 grams of iron. So it's just the calculations that we've been doing already, right? There's no difference here. It's just a mass conversion. So we can use our map, start with grams of Fe, and turn that into grams of Fe2O3. And we have calculated a theoretical yield. As simple as that. Right? It's just a new way of labeling, of asking that question, how much product should form. So take a pause here and see if you can do this calculation. All right, so did you get 0.715 grams of Fe2O3? If you did, you are on the right track. So let me do this for you, starting with 5.00 grams of Fe. My first step is to convert that to moles. 1 mole Fe is 55.85 grams of Fe. Cancels out grams of Fe. Right. Next up, the mole ratio. So I need moles of Fe to cancel, and I'm going to moles of Fe2O3. And from the balanced equation, Fe2O3 gets a coefficient of 2, and Fe is a 4. So put those in, cancel out moles of Fe, and then my final step, now that I have moles of Fe2O3, I can convert that to moles. So 1 mole Fe2O3, and the molar mass of Fe2O3 is 159.70 grams. Right, and run that through my calculator, I get 0.715 grams of Fe2O3. That is my theoretical yield. I calculated it. I didn't actually make it in the lab. Okay, a second type of yield is the actual yield, or it's sometimes called the experimental yield. And the actual yield is exactly what it sounds like. It's the amount of product that is actually obtained when you carry out the experiment in the lab. Right? If you're doing a lab, like we'll do in class, you can measure this. You can get out your balance and you can weigh your product, and you can see how much your experiment yielded. If you're solving a problem that involves an actual yield, you'll have to be told the actual yield some way, or given enough information to find it without using stoichiometry, right? Without having to go through what we just went through. So look for that in the problem, right? Usually the actual yield is less than the theoretical yield, and that's because as reactant gets turned into products, a lot of times it gets harder and harder for the reactants to find one another. And so if you're kind of trapped and surrounded by product that's already made, you might not have the opportunity to react. It's kind of like, even though that cookie recipe in the very beginning said that we were going to make 28 cookies, is that necessarily the case? Do you always get 28 cookies? At my house, that doesn't happen because even though I know I'm not supposed to, I usually eat some of that cookie dough. And it's kind of the same thing in the lab. Although, of course, you should never eat anything in the lab. Okay, and then our final type of yield is percent yield. And that is just exactly what it sounds like, right? You take, just like finding the percent for a test, you take what you actually got, you divide that by what you should have gotten, the theoretical yield, and multiply by 100. As simple as that. Okay, so let us do another example. Right? So this one says, during an experiment, 5 grams of sodium produced 11.6 grams of NaCl. Find the theoretical and percent yields. So when we look at this problem, right, the 5 grams of sodium's a reactant. And so that amount of sodium should be able to make some amount of NaCl. So to find the theoretical yield, I'm going to have to do stoichiometry, a mass-mass conversion, to work that out. Right? To find the percent yield, I know I need percent yield equals the actual yield divided by the theoretical times 100. So I will need that actual yield. I'm going to calculate the theoretical yield. I'll need the actual yield. So look at what the sentence problem here says. During an experiment, 5 grams of sodium produced 11.6 grams of NaCl. this thing right here, that is our actual yield. So just parse the sentence and kind of figure out what roles everything is playing. Okay, so we want to find our percent yield. So we've identified our actual. So let's calculate our theoretical mass problem. I'm going to start with my 5.00 grams of Na, and I'm going to convert that to the product NaCl to get my theoretical yield. Why don't you try this without me first? So give that a shot. All right, did you get 12.7 grams of NaCl? If you did, you got it correct. So let's see how this works out. Convert grams of sodium to moles. 1 mole Na has a molar mass of 22.99 grams. Now I'm going to convert moles of sodium to moles of NaCl. So it's 2 moles of sodium for every 2 moles NaCl. And once I have moles of NaCl, I can convert that to grams. So 1 mole NaCl in the denominator has a mass of 58.44 grams. And so that's where I got my 12.7 grams of NaCl. And now I can plug that in and find my percent yield. That's our actual divided by our theoretical times 100 equals, our actual was 11.6 given in the problem, divided by 12.7 times 100, and that works out to be 91.3%. Okay, so calculated the percent yield, wasn't a big deal. Just don't be confused by that word theoretical yield. If you're asked to find the theoretical yield or you need the theoretical yield, all you have to do is take whatever mass of reactant you're given and convert that into grams of the product that you're interested in. Now sometimes there might be more than one product, and then you should be given some guidance on which product to use. So just read carefully and you'll be fine. All right, and that is the end.